topic for this, this presentation, I would talk about fetal growth restriction, nutritional determinants, the consequences in childhood, and I emphasize in childhood because I know there are many consequences of fetal growth restriction and of course the early childhood growth in the first 2 years on adult chronic disease, and I acknowledge all those, but in the short space of time can't go into them. So I will talk about the definition of fetal growth restriction and the small for gestational age as part of that. Nutritional determinants, not to cover that exhaustively, but some new analyses we did in part leading up to the second series of papers in the Lancet on maternal and child nutrition. The consequences of being small for gestational age on mortality and on stunting, I think also very important, and the interventions, as I say. So first, a bit about low birth weight. You all know about low birth weight. It's very commonly used terminology. That is, newborns who are less than 2,500 grams at birth are considered to be, quote, low birth weight. This is widely used and I think appropriately used in programs to denote babies at additional risk. It's reported in global statistics, and globally it's said that about 15% of births are low birth weight. About a third of the babies in India are also said to be low birth weight, and this is mostly because of fetal growth restriction. So before I go on to SGA, I'll talk about low birth weight, which is probably what you're more familiar with. This actually shows statistics from UNICEF and the, to me, absolutely stunning number of children and the proportion of the global total of babies who are born in India with low birth weight. So 38% of the global total, dwarfing any other country. And you see the next two countries in the numbers being Pakistan and Nigeria. But what are the limitations of this categorization of low birth weight? Well, first, it's well known and it's been published for many years, decades in fact, in India as well, that low birth weight includes babies who are born preterm, so short gestational age, and those who have fetal growth restriction, or sometimes both. So using the 2,500 gram birth weight cutoff as the threshold for low birth weight, babies can have fetal growth restriction, but without being low birth weight. So as an indicator of fetal growth restriction, we will use being small for gestational age. And first, as a definition, we consider births less than 36 weeks to be preterm. And now our previous calculations, and we heard a bit of it in the presentations here in the meeting, use this, this terminology of term low birth weight. So that is babies who are born full term, but less than 2,500 grams. So this rectangle at the bottom here is the term low birth weight. So they're not premature, they're full term, but they're less than 2,500 grams. But I think you can see, and I'll have numbers on this, this slide later, but just for now in concept, you can see that there's another fraction here, this triangle, who are actually small for gestational age, even though they weigh more than 2,500 grams at birth. And in fact, there's some fraction of this group of the preterms that also have small for gestational age, so they have the combination of being preterm and SGA. So what we've been able to look at through a number of new analyses, and in fact forming investigators groups to share data and to do analyses according to certain definitions, we've actually now been able to estimate this full spectrum of SGA, not only the term low birth weight or the number of babies who are less than 2,500 grams. So fetal growth restriction, as I say, we'll use the small for gestational age definition that was set by a WHO expert group. We're using less than the 10th centile birth weight for gestational age, and you have to pick a reference population. There are, by our search, more than 26 different fetal growth reference populations in the literature. We actually chose to use one published by Alexander. It's actually a US population of more than 3 million births in the early 90s, And this actually is a widely used reference, and if you use some of the other references, you get different prevalences, but we're actually comforted that I'm told, because I haven't seen all the data, that there's a new multi-center fetal growth reference or standard study that's going on in multiple sites around the world. The fetal growth standard, if you will, actually now apparently looks very much like this Alexander reference, and in fact the fetal growth patterns for all the sites around the world look very, very similar. So I'm told we'll see these data before long. We actually had the ability to collect a lot of data and the willingness of investigators to share the data or to do analyses. So here's one methodology we use to collect these data. These are the data sets. These are predominantly community-based studies where very accurate gestational age was done, sometimes by ultrasound. And a few of these studies, particularly in Latin America, are hospital births, but in settings where almost all of the deliveries occur in hospitals. So it's a representative sample for those settings. So overall, more than 2 million births analyzed. The other data set we have is we work with WHO to utilize the data from a multinational health facility-based study or survey, and these are the 23 countries that were included in that, and including more than 200,000 births. And this has additional information that we could use for these analyses. So first I'm going to talk about the risk factors for fetal growth restriction and preterm birth, but particularly focusing on fetal growth restriction. Of course, maternal infections are part of this risk profile. Maternal morbidity, pregnancy morbidity, including placental insufficiency, multiple gestations, many reasons for poor fetal growth. There are various demographic associations that have been found, low maternal age or young women or high maternal age, short birth spacing, etc. And a number of environmental risk factors, smoking, of course, ambient air pollution. But I'm going to concentrate on the maternal nutrition risk factors, particularly being short stature, low BMI or underweight, and anemia. There are a number of ones that I don't have the new data on, so I do recognize that there are other maternal factors, nutritional factors, such as weight gain in pregnancy, sometimes in some studies being overweight, although I'll show the converse of that. So in regard to the nutritional determinants of SGA, we're examining the association of these factors: maternal short stature, maternal underweight, maternal anemia, and as I say, we don't have new data on the others, but the literature has other information. Here's the prevalence of maternal short stature in women of reproductive age. As you can see, the prevalence of short stature being less than 150 centimeters is very high in Southern Asia and Southeast Asia. So the region we're in being Southern Asia, these are UN regions. And the even shorter stature being less than 145 centimeters is more common in these regions as well. This looks at the relationship between maternal short stature and the risk of being small for gestational age at birth, the baby being SGA. These are adjusted relative risk. We do adjust for other covariates and potential confounding factors that we have available. I think what you can see is these adjusted relative risks are highly statistically significant in all cases. They're not very large, but given the very high prevalence in some areas, this still constitutes a sizable risk. And in comparison with the other studies that are in the literature, they used different kinds of comparisons, but the WHO maternal anthropometry study finds a similar odds ratio of 1.2. Our composite would be similar to that. And then this knowledge synthesis group, also with a meta-analysis, found overall a risk of 1.23. So think we find very similar results. When we calculate the population attributable fraction, this is the kind of formula we use. It takes into account the prevalence of the exposure, in the case I just mentioned, short stature. It takes into account the relative risk that is derived from these analyses, and then it compares that risk to a counterfactual of the theoretical minimum exposure to that risk factor, and then adjusts as much as possible for other possible explanations. And so I won't repeat this, but we're using this method of population attributable fraction for a number of the analyses that I'm going to show. So the first one is SGA births, and the total number of SGA births by region. Africa, Asia, and Latin America is on the left part of this panel. And the dark part, the brown part of that, is the proportion of the SGA births that we can attribute to maternal short stature using this population attributed fraction approach. 22% in fact in Asia. This shows some trends in low and high BMI prevalence. We published this in the 2013 Lancet series on maternal and child nutrition. And I think the first thing you can see is, let's just take Asia on the right here. The prevalence of low BMI, women in reproductive age group being too thin, BMI less than 18.5, has plateaued. There was some decline earlier, but in the 80s, but recent 2 decades, this has plateaued and is almost 15%, is about 15% in Asia. There's also, as you see, an increase in overweight, so BMI of 25 or more, and so that's a worrisome trend. Asia still looks much better, though, than the Americas, where the prevalence of high BMI is up approaching 60% in reproductive age women. This is the analysis of maternal BMI and the risk for SGA. On the left panel, low BMI, less than 18.5, and you can see overall a statistically significant effect of about 1.4. And high BMI actually has a protective effect. Now, these are not, in these analyses, obese women. These women have BMIs that are not very far from 25, but nevertheless, there is a reduction in SGA in the women who are overweight, a reduction by about 1/3. And in comparison with prior studies, again, the 2 studies that I mentioned before, now looking at low BMI, find similar results, adjusted relative risk of 1.5 in one, 1.8 in the other versus our 1.4. So similar. And also this knowledge synthesis group had an adjusted relative risk of 0.69, where we find 0.68 for for SGA in women who have a BMI of 25 or more. So now we look again at the attributable fraction, and for Asia, we get about 7% of the SGA being attributed to low maternal BMI. We looked also at anemia. This is a bit complicated to see, but just the bottom part in the red tells the story. Moderate to severe anemia, but not mild anemia, is associated with an increased risk of being SGA, and the relative risk for SGA is 1.5. This is all anemia, not necessarily iron deficiency anemia. So we go through the calculations again. The SGA attributed to maternal anemia is relatively small, but it is still significant. Now I'm going on to what is the prevalence of SGA. I first wanted to talk about the nutritional associations with SGA. And there are, as I said, many other determinants or other nutritional determinants we're not looking at, but it is very clear that maternal nutrition is an important part of the story of fetal growth restriction. So now we've done a number of estimates of the prevalence of SGA in the world, And so we've just published this in the Lancet series, as well as in a paper in Lancet Global Health, the companion journal of the Lancet. And we also wanted to look at this in regard to the co-occurrence with preterm birth. Complicated set of analyses, which I won't go through in any detail, but we had to do separately the calculations related to term small for gestational age, and then do modeling so we could get country level estimates using national covariates, having study level covariates, and then getting national level covariates to model the country prevalences and then add that to the regions. For preterm birth, we actually started with estimates that we had published previously on the prevalence of preterm birth. These are from the Child Health Epidemiology Reference Group that I chair for WHO. And this was published 2 years ago now in the Lancet. So estimates of preterm birth, but here we wanted to look at what proportion of those preterm births were also SGA. And this is an overall summary of the prevalence of SGA and preterm birth by UN regions. Sorry, these are UN MDG regions. But just take South Asia on the far left here. The bottom part here in the purple is the preterm appropriate for gestational age. So these are not SGA. But all of the rest here, this very large red part and then the darker purple one in the middle, smaller slice, these are SGA. And if you compare that with the prevalence of low birth weight, which is the lighter blue bar next to that, you'll see that the prevalence of SGA is not quite double that of low birth weight. So we have a substantial additional number of children or proportion of children at risk. You can also see, of course, that the highest prevalence of SGA is in South Asia. This is a map of the global prevalence of SGA in 2010. The darkest color here is a prevalence of 40 to 50%, and India is in that category, along with just a few countries in South Asia and in Africa. The estimated prevalence of SGA in India is 47%. Similar to Pakistan, and much higher than countries in Africa that follow. This actually shows on the same map the pies. The size of the circle is the proportionate to the number. The nutritional risk factors are shaded in. This is certainly an underestimate of the nutritional risk factors, I'm sure, but it just shows that the nutritional risk factors play, I'm sure, a more important role in Asia than they do in other areas of the world. So now I'm going on to another important aspect, which is, what is the concern about SGA? Is there an increased risk of mortality? And so we've looked at the left part of this diagram already, nutrition as a risk factor, but now I want to look at the SGA as a risk factor for mortality. Now I'm showing this figure with some numbers in. These are from the Asian data sets that we were able to analyze. Here's the term low birth weight at the bottom, 15%. There's another 8% over here. So there's 23% who would meet the criteria of less than 2,500 grams. But in fact, this triangle has another 21%. So again, we're approaching doubling the number of babies at risk in Asia. So this shows the additional relative risk of death in the neonatal period, the first 28 days of life, if the baby is born SGA or preterm or both. So this is all in comparison to babies who are born full term and appropriate for gestational age. The first set of numbers, these three numbers, is for babies who are term SGA. They're full term and SGA. So they have between a 2 and a 5-fold increase in mortality in the first month of life, just from being SGA. This one is preterm and appropriate for gestational age. They, of course, also have an elevated risk of mortality, slightly higher. And the combination of being preterm and SGA is much higher than either of those, in fact, more than additive. So we have a very elevated risk of mortality from being SGA. And here we've done again our attribution of deaths to SGA. This is all low and middle income countries. This is for 2011, which we used in the nutrition series. The total deaths in that period in the world would be 6.9 million, and we're attributing more than 800,000 of those deaths to in the neonatal period to SGA, and another 400,000 post-neonatal deaths. In total, more than 1 million deaths, or 18% of total deaths. Now, these are the attributed fractions. Of course, I must say that we're talking about the synergy of nutrition and infectious disease, particularly, that is the cause of these deaths. So these babies are not dying uniquely and solely of being small for gestational age, but that fetal growth restriction, that nutritional deprivation, puts them at higher risk of dying of causes such as infections in the neonatal period or the post-neonatal period. This comes from the nutrition series, and I just wanted to show for perspective. For the series, we only used in the calculation the neonatal deaths attributed to being SGA, and that's the first row of this table, the fetal growth restriction in the first month, so the 800,000 deaths, as I said. This is very similar to the number of deaths that can be attributed to stunting or underweight or wasting in the children who are 1 to 59 months of age. And then I show also zinc and vitamin A deficiencies in regard to their attributed burden, suboptimal breastfeeding as well, and then the total, and using methods that do not double count these and look at the joint distribution of all of these together, we can say that 45% of all of the under 5 deaths have undernutrition as an important underlying cause, and that's 3 million deaths in the world. We also looked at the infant deaths attributed to SGA by region, and I show this because, of course, a very high number of those are in Southern Asia. And then a calculation specific for India. Deaths attributable to SGA in India by our calculations would be neonatal deaths, 390,000, post-neonatal, 146,000. So about 45% of neonatal deaths and about 30% of all under 5 deaths have SGA as an important underlying cause. So conclusions on this part in regard to mortality are first that the prior analyses use the term low birth weight category as a proxy for intrauterine growth restriction or fetal growth restriction. And this excludes a large proportion of the term SGA babies who are at increased risk of mortality. As I've said, the prevalence of SGA is much higher than preterm prevalence, especially in South Asia. And in many areas of the world, you hear low birth weight and people say, oh, that's because babies are preterm. Well, in fact, in some other areas of the world, Latin America, that may predominate. But in Asia, certainly, the fetal growth restriction predominates in the low birth weight babies. And so what we've said that approximately 1.3 million deaths of infants could be averted by preventing the SGA births, and more than 500,000 deaths in India, likewise, could be averted without the SGA births. Now, the mortality statistics are strong enough, but the other consequence of being fetally growth restricted has to do with growth in the first 2 years of life. So we also wanted to look at the prenatal origins of childhood undernutrition, particularly of stunted linear growth. So we're looking at the odds ratios for childhood stunting. We also did, but I'm not presenting, wasting and underweight, associated with being SGA and also preterm birth, and used the data from the existing birth cohort studies in low-income countries. Actually, I think all of these cohorts were low-income countries when they started. Some, like India, have graduated into being now middle-income countries, but nevertheless, most of the data are older from the low-income period. These are from prospective follow-up studies and measurements of subsequent child anthropometry. and they estimate the proportion of stunting attributed to being fetally growth restricted. Briefly, the methods are, we're looking at stunting being the height for age of less than -2 z-scores, and we look at odds ratios because of the access to data that we have. We have also controlled for confounding factors such as sex, parity, maternal age, and in all of these analyses, as the previous ones, the full-term babies who are appropriate for gestational age are the reference category. So in this case, actually, the SGA at term, I'll show this is the middle panel. So these babies are full term and SGA. So they have, again, between a 2 and 3 or more fold increase in the odds of stunting at 24 months of age than appropriate for gestational age babies. Over here is the preterm and appropriate for gestational age. They also have an increased odds for stunting. And then again, the combination of being both preterm and SGA is even worse and even higher risk. So we do the population attributed fraction again for stunting attributed to SGA and preterm. And I'll just go to the bottom line here, that globally we say that 20% of stunting is attributed to being SGA and 5% to preterm births, although there is substantial regional variation, as is shown here. And to show the importance of that regional variation, I'll go directly to India. In India, the prevalence of SGA is about 45%, and the attribution of being born SGA for stunting is about 35%. So because of the higher prevalence, using the same risk ratios, we're able to say there's an even higher fraction attributed in India. So briefly about interventions, I'm not going to talk about the whole range of interventions, but I will mention that one very important one is optimizing the age at first pregnancy and the lengthening of interpregnancy intervals to first improve the growth of girls so that they don't get pregnant before their growth has terminated, and then for the interpregnancy intervals to lengthen to a point that the mother is healthy to give birth again. I'm not going to talk about some of the other aspects related to calcium, maternal morbidity, or tobacco, but I will mention a few interventions that come out that have to do with maternal nutrition. The first is the importance of improving the diet of women in pregnancy. What I'm talking about here is the trials have been done with balanced protein energy supplementation, but in fact what we're talking about is local foods, improved diets with sufficient calories, protein, and most of these did some micronutrients, but not generally a full range of micronutrient supplements, but certainly they often gave iron and folic acid. So you can see that that overall from this analysis, the effect on being SGA is highly significant, about a 1/3 reduction in SGA in women who are randomized in these trials to receive balanced protein energy supplementation. So a clear indication that improved diets in these populations that are largely food insecure households or selected in various ways to identify them as potentially in need of additional food. The other analysis to present is in relation to multiple micronutrients in pregnancy. There is overall in the trials that have compared iron and folic acid with no iron and folic acid or placebo, some benefit on small for gestational age. But this is a comparison of multiple micronutrients, a full set of vitamins and minerals, in comparison to iron and folic acid. So the controls here all receive iron and folic acid. And in fact, the multiple micronutrients find a further reduction in SGA burst of about 11%, again a significant finding. So it is saying that in addition to iron and folic acid, which is certainly recommended and should be used in pregnancy, the full set of micronutrients appears to provide additional benefit. And here's the overall summary of that. The small for gestational age is the 11% benefit. It's also interesting, and these analyses, that what were called brand new estimates, include the preliminary results of a trial our group did in Bangladesh on multiple micronutrient supplements in pregnancy compared to iron and folic acid. Very large trial, more than 40,000 pregnant women. And overall, including those results, there's an effect both on the SGA burst, but also a small but statistically significant effect now overall on preterm bursts as well from supplementation with multiple micronutrients. So the conclusions, I would say, for nutrition interventions to prevent SGA are that improved diet, the trials used to balance protein energy supplements in food insecure households could reduce the prevalence of SGA bursts by 1/3. Multiple micronutrients, perhaps 11%. We're not really sure how these two interact, whether they're additive or to what extent they overlap, but both have shown benefits. The overall conclusions I would give then are that SGA is a very important global problem. It has consequences for child survival and for growth and for stunting particularly. The risk of mortality and stunting is not only in babies who are born less than 2,500 grams, but includes all those who are small for gestational age. Importantly for this audience, India has a high proportion of SGA births, 47%, and these have important consequences: more than 500,000 child deaths, 21 million stunted children. And there are interventions that can possibly have an effect, but we also know that there are intergenerational effects. There are disease-controlled interventions that might also have effects. And so I think these two are not all that we would wish to do. And I would also say I focused on small for gestational age as a consequence of maternal nutrition. There are also issues about adolescent nutrition and the preparation of girls going into the time of conception. And of course, there are many benefits of good nutrition for girls and for women that go beyond their reproductive roles. And we do deal with those in the Lancet series. I don't have time to talk about all of them, but would certainly want to add that we're interested in maternal nutrition for many reasons, and in the nutrition of women for many reasons, not only for their offspring. So thank you very much.